All right, we are back in business here. So let's keep going. Number 45. What kind of decay is happening here, and explain how you know. Okay, so let's look at what's going on. You've got this big nucleus, and now you've got a smaller nucleus, and we've released a particle that has a mass of 4 and 2 protons. What does that sound like to you? That's alpha decay. Recognize that. If the mass goes down by 4 and the atomic number goes down by 2, that means that it's alpha decay. How about letter B? The mass is 14 and it stays 14, but the atomic number has gone up from 6 to 7. You should recognize that as a beta decay. Again, the mass has no change, 0 change, and the atomic number increased by +1. Letter C. An isotope of lead decays to form an isotope of mercury. So if you check it out on the periodic table, lead is number 82, mercury is 80. So that means the atomic number has gone down by 2. Atomic number went down by 2. We should recognize that as an alpha decay. Finally, the last one here, we've got a big nucleus and the mass stays the same, but the atomic number went up by 1. That's a beta decay. All right. Band of stability questions. Let's see if I have any of these pulled up yet. I'm going to take a second and open up a band of stability so that we can check it out while we're going over this. Okay. First of all, it says, what happens to the proton to neutron ratio as the atomic number goes up? Okay, so let's look at our band of stability here. Remember, this gray island here is where atoms can exist. So as atoms get larger and larger, this is the line of protons equals neutrons. You can see as there are more protons, you actually need more neutrons. Those are the glue that hold the atoms together. So as atomic number increases, the ratio increases. An atom that has 80 neutrons might have how many protons? So let's check out our chart here. It's got 80 neutrons, so we want to go to the 80 on this chart. Okay, so we're at the 80. Go over to it. How many protons might it have? So the edge of it starts here, go down. I'm going to approximate that at like, I don't know, 54, 55. Go over to this side, 80, and then go down. That's maybe at 67 or so. Okay, so what elements could it possibly be? So if it's between 54 and 67, I mean, if your numbers are slightly different, that's fine. I'm going to look up those elements. Number 54 is xenon, and number 67 is HO. Okay, would an atom with 90 protons and 90 neutrons be stable? Let's check it out. 90 protons, 90 neutrons. Whoa, we would be way over here off the chart on this line. So not even close to being stable. No, not stable. And for your explanation, you can write it's not on the band of stability. How do you determine whether an element is radioactive? If it lands on the edge of the band of stability, it's radioactive. If it's got more than 83 protons, it's radioactive. And by the way, radioactive, how can you even define radioactivity. What does that mean? That's when the nucleus is decaying. It's falling apart. Nucleus is decaying. And in that process, it's releasing particles and energy at the same time. So that's what radioactive means. All right, now we're supposed to write some nuclear equations here. They don't give us a ton of space. But first we've got polonium-208. So I'm going to write the mass in the upper left. And polonium is number 84. And if it undergoes alpha decay, it's losing a chunk of itself that has a mass of 4 and 2 protons. So we're going to subtract. This is like the Rice Krispie treat. If you had a mass of 208 and you're losing a chunk that weighs 4, it's only going to weigh 204 now. And 84 minus 2, it's only going to weigh or have 82 protons. So look up what element will it change into. Number 82 is lead, Pb. All right, how about a beta decay? We've got sodium 24, sodium's number 11, and it's losing a beta particle. And these are kind of freaky because the mass doesn't change, but the protons go up by 1 because a neutron changes into a proton. So now we've just made a magnesium. And for the last one, it's a fusion. So fusion means adding. So we've got a helium and we've got a neon. And I'm looking up their atomic numbers and writing those in the lower left. Actually, I'm a nerd, so I have them memorized, but you guys will look those up. 20 plus 4 is 24. 2 plus 10 is 12. So we just made a magnesium again, but this time with fusion. All right, moving into calculating moles. I want to remind you what a mole is anyways. If you talk about you want a dozen of something, you want 12. If you want a mole of something, you want 6.02 times 10 to the 23rd of it. And why would you ever want that many? Well, if you want a lot of atoms or molecules, because they're so small, it would be so hard to write out these giant numbers all the time. So you're going to need the periodic table to figure out what the atomic masses are, the molar masses, so that you can do these calculations. So always start by writing what you know. Here you've got 65 moles of sulfur. How much would that amount of moles of sulfur weigh? Well, set it up. You can figure out how much 1 mole of sulfur weighs by looking on the periodic table. 1 mole of sulfur weighs 32.07 grams. So, how much would 65 moles weigh? You've got to multiply across the top and divide by the bottom. So this comes out to be 2,084.55 grams. And then if you're rounding with significant digits, it'd be 2,100 grams. How about 49? What if you're starting with grams and you want to know how many moles you have? So here you've got 435 grams of sodium. How many moles do you have? Well, you've got a lot because 1 mole of sodium from the periodic table weighs 22.99 grams. And you've got way more than that. You've got 435 grams. 1 mole weighs about 23 grams, so how many moles do you have? Multiply across the top, divide by the bottom. Notice grams are going to cancel out, and you're going to be left with moles. So 435 times 1 divided by 22.99 ends up being 18.9 moles of Na. All right, and the last one here is a great exercise. It says you've got 50 aluminum soda cans and they weigh 2,250 grams. And it says, how much would 5 soda cans weigh? Well, first let's figure out how much 1 can weighs. I think my computer is not responding again.